Swayam Prabha. Digital India. Educated India.
Welcome to Lecture 6, Numerical Problem Part 2. We will be continuing the same problem. Before continuing the problem, so in the problem it was clearly given that the condition of refrigerant is superheated to a temperature of minus 10 degrees centigrade. That is, the temperature at this point is minus 10 and it is compressed isentropically from state 1 to state 2. So we need to find out the properties, the enthalpy, entropy at state point 1 dash, which is the saturated properties. But for state point 1 and 2, we need to evaluate the superheated conditions. So I think I have stopped at this point. I think we were calculating about the CP value, about the, yes, I think we were calculating about the CP value. That is for the state point 2, the equation S2 minus S2 dash equal to CP of vapor into ln of T2 by T2 dash. Because T2 temperature is unknown. T2 temperature is unknown. So I will be continuing from here. So this is the equation S2 minus S2 dash is equal to CP of vapor into ln of T2 by T2 dash. Here T2 is unknown. T2 is unknown. We need to find S1 is equal to S2. That value is known. Because 1 to 2 is isentropic process. S2 dash we have already found from, that is the saturated entropy corresponding to the temperature at T2 dash. Then T2 dash temperature is also given. So if you go to the previous slides, let us take the value of S2 dash. S2 dash is SG value. S2 dash is SG corresponding to temperature of 32 degrees centigrade, which is the condenser temperature. So now we need to take the CP value. Since we don't know the temperature T2, so instead of taking it average of T2 and T2 dash, we have to take corresponding to T2 dash whatever is the CP value from the table. So the T2 dash is 32 degrees centigrade. T2 is unknown. So let us find out the CP value. CP of vapor at T2 dash is equal to 32 degrees centigrade. Since this is not known, we cannot take the average. Since T2 is unknown, the average of T2 and T2 dash is not taken. Now let us go to the refrigerant tables corresponding to 32. So CP of vapor is 1.058. 1.058. Let us check. 1.058. This is the CP of vapor corresponding to T2 dash, which is the which is equal to the condensate temperature of 32 degrees centigrade. Therefore, Cp of vapor is equal to 1.058 kilojoule per kg Kelvin. Now, in this equation, S2 dash is known, S2 is known, Cp of vapor we have just found from the table, T2 dash is given. So, we can substituting all the values, substituting the values of S2, S2 dash, Cp of vapor, T2 dash, we get S2 is S1 equal to S2. S2 is 1.7. S2 is nothing but S1, which is 1.7643. S1 is equal to S2, 1.7643. Let us check the value once again. If you look at the diagram, 2 dash is on the saturated vapor curve corresponding to 32 degrees centigrade, which is the condenser temperature, So let me check the value once again. Corresponding to 32, vapor entropy is this one, 1.7142. 1.7142. This is the value. So this is what I have substituted here. Okay, S2 dash is 1.7142. S2 dash I will write it here. S2 dash is equal to 1.7142 kilojoule per kg Kelvin. And S2 is nothing but S1. S2 is nothing but S1. So we have found out somewhere else S2 equal to S1. 1.7643. This is S1. 1 to 2 is isotropic process. Therefore, S1 equal to S2. S1 equal to S2. 1.7643. S2 is equal to 1.7643 kilojoule per kg Kelvin. So these are already we have found. So substituting these values, 1.7643 minus 1.7142. So Cp of vapor is 1.058 into ln of T2 is unknown. T2 dash is 32 degrees centigrade. We have to convert it into Kelvin. So 32 plus 273. So solving this one, we get the temperature T2 as 320.3 Kelvin, which is equal to 47.3 degrees centigrade. 320.3 Kelvin, which is equal to 47.3 degree centigrade. So the refrigerant is compressed from state 1 from a temperature of minus 10 degrees centigrade to a superheated state of course, state 1 is also superheated condition in this case, 2 years discharge temperature of 47.3 degree centigrade. 47.3 degree centigrade. Now it's easy to find out the enthalpy at state point 2 using the formula H2 is equal to H2 dash plus Cp of vapor into delta T. So this is nothing but H2 dash plus Cp of vapor into T2 minus T2 dash. Let me go to the diagram. So enthalpy at state point 2, superheated condition equal to saturated enthalpy plus Cp of vapor into delta T. Delta T is T2 minus T2 dash. Okay, this is what. So now we need to find out H2 dash. H2 dash we can find out similar to S2 dash. At state point 2 dash is in saturated vapor state. So the corresponding to the condensate temperature of 32, we can find out the vapor enthalpy. So this is the equation. So here H2 dash is equal to Hg at T2 dash. T2 dash is equal to T3, which is equal to condenser temperature, which is equal to 32 degrees centigrade from R134A table. 134A table. So let us take the value corresponding to 32. This is liquid enthalpy, this is vapor enthalpy, 415.9. So the enthalpy at 2 dash equal to 415.9 kilojoule per kg. Kilojoule per kg. So now we have to substitute these values. Substitute H2 dash Cp of vapor. Cp of vapor to be found out for the average of T2 and T2 dash. So before substituting, let us find out the Cp of vapor. Cp of vapor to be found out average of at T2 plus T2 dash by 2, which is equal to T2 just now we have found 47.3 plus T2 dash is 32 by 2. If you take 80 approximately, I think it comes around 40 degrees centigrade. So Cp of vapor, it comes around 40 degrees. See, this is the Cp of vapor value from the table for the average temperature of T2 and T2 dash, which comes close to 40 degrees centigrade. So let us go to the tables. So this is approximately 40 degrees centigrade. So therefore, from R134A table, at 40 degrees centigrade, Cp of vapor is equal to, so this is 40 degrees centigrade. Cp of vapor is the last column, 1.120. Let us check the values. 1.120 kilojoule per kg Kelvin. Let us take this equation as equation number, equation A. Equation A. Substitute values of H2 dash, Cp of vapor, T2, T2 dash in equation A. In equation A. So therefore, we get enthalpy at state point 2 equal to H2 dash enthalpy is 415.9 plus Cp of vapor is 1.120 into delta T, T2 minus T2 dash. T2 is 47.3 minus 32 degrees. So we will get the enthalpy at 2 is equal to, we substitute we will get 433.04. This is the value of H2. 433.04. 433.04 kilojoule per kg. This is the. Now we have found the enthalpy from state point 1, state point 2. Only state point 3 is pending. So it is directly can be taken from the tables. State 3. So enthalpy at state point 3 is equal to liquid enthalpy at 3 corresponding at T3. T3 is nothing but Tc, which is nothing but T2 dash equal to 32 degrees centigrade from R134A tables. So corresponding to 32 degrees centigrade, liquid enthalpy 254 point. Let me, the letters are not, 244.55. 244.55. Therefore, H3 is equal to 244.55 kilojoule per kg. So this is equal to H4. Since 3 to 4 is isenthalpic process, that is enthalpy at 3 is equal to enthalpy at 4, 244.55. Now let us compute the various parameters. The first one is evaporator heat load. So before that, let me mark m dot because it is MR is the due to some system configuration. So the dot is not clear. So let me, this is m dot R, and when we calculate this one, here m dot R will come. This is m dot R. This is also m dot R. H1 minus H4. So m dot R into H1 minus H4. So if you calculate, m dot R is given in the question, 0.05 kg per second. So it comes around 7.5 kilowatt, 7.5 kilowatt. And work of compression is m dot R into H2 minus H1, because the refrigerant is compressed from state point 1, which is superheated state, to a superheated state of state point 2. So WCO comes around 1.93 kilowatt. Second part of the question is condenser heat load. QC is equal to m dot R into H2 minus H3. If you go to the diagram, this is the work of compression. This is from 2 to 3, it is the condensation. H2 minus H3. So it comes to 9.43. 9.43 kilowatt. And the COP of the system is the ratio of refrigerating effect, QE, to work of compression. So 7.5 divided by 1.93, 3.89. Energy balance, QE plus WCO is equal to 7.5 plus 1.93. This is equal to 9.43, which is equal to the condenser heat load. Let me tell the properties, the refrigerant tables and charts. Of course, I have used the tables for taking the properties. I have used the refrigerant tables and charts by C.P. Raman. All the values are taken from that one. Refrigerant tables and charts by the author C.P. Raman. So there are various publishers, different authors, a lot of tables are available. You can refer anyone, but you refer uniformly for all this one, for when you are solving the problems. I'll just show this is the pressure enthalpy chart, which is from the same refrigeration table published by C.P. Raman. So this is for R134A, the refrigerant which we have used for solving the problems so far. So this is R134A tetrafluoroethane. So here if you see, this is the saturated liquid line. This is the saturated vapor line. These are constant entropy lines. These are constant entropy lines. Constant entropy lines. Suppose if state point 3 lies on the saturated liquid line. So, and this is the y-axis is the pressure. It's a pH chart. and x-axis is the enthalpy. So once we know the temperature, evaporator and condenser temperature, using the tables we can find out the pressure, evaporator pressure and condenser pressure, evaporator pressure, condenser, or even here also the lines are there. These are all the isothermal lines. So for example, corresponding to minus 18, the pressure is corresponding to minus 18. The pressure is 1.44 bar, 1.44 bar. Similarly, corresponding to 32 degrees centigrade, the pressure is around 8 bar, 8.15 bar. And so this is in this one. So we can easily plot 8.15 bar, 8.15 somewhere else comes here. And so the state point 3 will come somewhere else here. So this is 4 bar, this is 10 bar, 7, 8. So this is around 8. This is 8.15 bar. That is the condenser pressure. So the state point 3 will come somewhere else here. And if you see the enthalpy value at 3, it is 244. If we use the chart, this is state point 3. This is the saturated liquid line. Saturated liquid line. Liquid line or liquid curve. Saturated liquid line. So somewhere else is here. So if I extend this one, once I fix the point, saturated liquid enthalpy line, so extend the point and draw a perpendicular line, I will get somewhere else here. So here it is, the next dark line, the value is 250. So somewhere else it comes around 245 kilojoule per kg. When we compare with the value from the table, it is 244.5. 244.5. Of course, when the learners are using the chart, it is suggested to use a scale pencil, mark the point properly, because in this problem 1 dash and 2 dash are in saturated condition, saturated vapor curve. So we need to fix 1 dash and 2 dash. That will come on this side. It will come in this region, saturated region. It will come on this region. So this is the saturated vapor curve. These are constant entropy lines. So once you fix 1 dash and 2 dash, directly we can read the value, enthalpy value, by drawing a line from that point perpendicular to the x-axis and read the value from the x-axis. So with this, I conclude this lecture. Thank you.